Hey scholars, today we're going to be talking about revolution, which is the movement that the Earth does as it's orbiting the Sun. So last time we talked about the first way that Earth moves, and that's through rotation. And remember, rotation was keeping in mind that there is an axis or an imaginary line that goes through the center of the Earth. And rotation is when the Earth is spinning on its axis. So I told you to picture somebody doing a basketball trick where they're spinning the basketball on top of their finger. That is how the Earth spins on its axis. Today we're talking about a second way that the Earth moves, and so while it is rotating, giving us night and day, the Earth is also doing something called revolving. So our I can statement for today, getting started, we are going to be talking about how I can explain how Earth rotates on its axis. That's what we did last time. And our new part today is and revolves around the Sun. So we'll get started by writing today's date, which is February 22nd, 2021. And again, we're focusing today on how does the Earth move, but specifically with revolution. So, true or false, I kind of already gave this one away today, but the Earth is always moving. Everyone should be giving me a thumbs up, right? The Earth is always moving, and not just in one way, but now we're learning today a second way. So last time we learned that the Earth rotates on its axis. Here's the Earth, tilted on its axis, which means it's not standing upright, but it's leaning to one side. And we learned that it takes 24 hours or 1 day for a full rotation to occur. Now we're learning that as the Earth is rotating on its axis, it is also revolving around the Sun. And that's what we're seeing here in this graphic. So it's not that we have 4 Earths going around the Sun. Nope. This is just showing the movement as it's moving around the Sun. And it moves in what's called a circular orbit. So Earth is always moving in 2 different ways. The Earth rotates or spins on its axis, and it also revolves around the Sun. And what we just heard is revolution or revolving is when an object goes around another object in a circular orbit. So now we're going to talk about how long it takes for the Earth to make one full revolution. So if you remember from last time, spinning on its axis, one full rotation is 24 hours. And that's why we have day and night, right? As the Earth is spinning on its axis, the time that we're facing toward the Sun, we experience daytime. As we face away from the Sun, we experience nighttime. So one full rotation or spin takes 24 hours. Well, now we're going to learn that as we go around the Sun in its orbit, one trip around the Sun takes 365 days. And in this case, it says 365.25 days, which is true because technically it's even a little bit more than 365 days for one full revolution. Maybe you've heard of a leap year. That has something to do with it taking just a little bit more than 365 days. So coming back to our notes, one full revolution or trip around the Sun takes about 365 days, and maybe you've heard that number before because 365 days is the same as one full year. So there are 365 days in 1 year. So we've learned over the last couple weeks that the Sun is at the center of our solar system. And we've also learned that Earth is the 3rd planet in the solar system. So we know that the Earth revolves or has revolutions around the Sun, but now we're going to just keep in mind that Earth is not the only planet that revolves around the Sun. In fact, all of our planets also revolve around the Sun. So Earth orbits the Sun at a speedy rate of about 18.5 miles per second. So say that again, 18.5 miles in just 1 second is how fast we are moving as we are revolving around the Sun. And another kind of impressive fact is to make that trip all the way around the Sun, the Earth's orbit, it is 584 million miles. And so we said it takes us about a year to go that far, a year to travel 584 million miles. So that should give you an idea of just how fast Earth is revolving around the sun. But like I said, Earth is revolving around the sun, but so are all of the other planets. So all planets revolve around the sun because the sun is the center of our solar system. And the reason I want us to keep that in mind is because we didn't always realize that the sun was the center of our solar system. For almost 2,000 years, people believed that the Earth was the center of the solar system. And the reason behind that is because we lived on Earth, so we assumed that we, humans, must be at the center of the solar system. So we believed that all of the other planets and the sun actually revolved around us. But now we know that that is not true. In fact, all of the planets, including Earth, revolve around the sun. So here's kind of what we used to think was true. Notice the Earth is at the center, but now we know that really the sun is at the center of the solar system. So on that same note, planets that are closer to the sun have shorter years than planets that are farther from the sun. They have longer years. And this happens for two main reasons. So the first reason is if a planet is close to the sun, then its trip or its orbit around the sun is fairly short. The other reason is the closer a planet travels to the sun, the more the sun's gravity can pull on the planet, and the stronger the pull of gravity, the faster the planet orbits. And while we're on this slide, maybe you've heard someone say that you have taken another trip around the year. Maybe they've said that to you on your birthday. Not trip around the year, trip around the sun. Maybe someone has said, oh, another trip around the sun for you on your birthday. And the reason someone might say that is because it took one full year for us to go around the sun. And so it's kind of a just another way to wish someone happy birthday is by saying, oh, you made another trip around the sun, thinking you made it another year on Earth. Just a fun fact for you. So thinking about what we just heard, depending on where you are in the solar system, planets that are closer, let me go back one more, planets that are closer to the sun are going to have shorter years versus planets that are farther from the sun are going to experience longer years. Let's take a closer look at that. So Mercury, we know, is the closest planet to the sun, and so a year on Mercury is only 88 days. On the other hand, Neptune is the farthest planet from the sun, and a year on Neptune is 60,190 days. So again, really emphasizing the farther you are away from the sun, the larger that orbit is, which means it takes much larger to revolve around the sun, which means 1 year is much longer on those planets. Here we've got Earth, 365 days, and again, noticing planets that are closer are going to have shorter years, and planets that are farther away, those outer planets, are going to have especially longer years. Pretty interesting. So just to kind of recap what we've been talking about, rotation, or imagining spinning like a basketball or spinning on its axis. And rotation is what gives us night and day, because as the Earth spins or rotates, when we face toward the sun, we're experiencing daylight or daytime, but when we rotate away from the sun and we're in the Earth's shadow, we're experiencing nighttime. Revolution, on the other hand, is thinking about the movement of the Earth revolving or going all the way around the sun. And you'll see all of the planets and their orbits here. Again, noticing that the further out you get into the solar system, the larger those orbits become, and that's why those planets, the outer planets, have much longer years. So before we finish our notes and you guys begin your independent working time on the rest of your assignment, I want us to draw a model, kind of like we did last time, to help us kind of bring everything together that we've learned today. And so we're going to start with the sun, because the sun we talked about today, as a review, hopefully the sun is the center of the solar system. So I'm just going to draw a quick sketch of the sun. And then I'm going to draw planet Earth, and let's see if you remember what we drew for planet Earth last time. We drew that the Earth is split into two parts, or two hemispheres, and this line that cuts the Earth in half, imaginary line called the equator. The hemisphere on top is the northern hemisphere, and the hemisphere on the bottom is the southern hemisphere. And the last thing we need to draw on our Earth is the axis. But notice I'm not going to draw it straight up and down because we know the axis is actually tilted. Now, rotation meant that the Earth was spinning on its axis. Now, revolution, what we're learning about today, is the orbit or the path that the Earth makes as it travels around the sun. And so just as a note to label our diagram that we just drew, I'm going to write Earth revolves around the sun. And we're going to continue to add on to this drawing a little bit more each time, really keeping in mind thinking about how the Earth is tilted on its axis and how its revolution or trip around the sun. Next time we're going to learn how that gives us different seasons here on Earth. So take a few more seconds to finish your drawing. And when you're ready, you can go ahead and continue on in your assignment today.